Let's look at this previous problem once again from the topic limits, continuity and differentiability, right? It says a function f maps from real numbers to real numbers. That means the inputs are real numbers, the outputs also are real numbers. Be a differentiable function, right? So the function is differentiable. It's differentiable everywhere, having f of 2 equal to 6. This is an important data, it's fixed, and f dash 2 is equals to 1 by 8. So at x equal to 2, the value of the function is 6 and the value of its derivative is 1 by 48, right? So you need to find this. You need to find, this is a comma, right? Don't get confused of f of x with this, right? This is a comma. So you need to find this value. So let's see. Let's actually how do we always start? So whenever there is a limit problem, x tends to 2, we'll first put the limit. We'll first put the limit in the required thing. So this is the function. This is the function of x. It's a capital Fx, right? This itself is a function of x, this entire thing, and I need x tends to 2 for this. So I'll put f of 2 in the function. So like wherever x is there, replace it with 2. So what you have is t cube divided by x minus 2 dt. In fact, this x minus 2 has got no job in the integral because the integral is with respect to t. So you can bring it out, and what you have is 1 by x minus 2 into integral 6 to f of 2 4t cube dt. As you can see, if I put x equal to 2 in this, this is becoming 0, and because f of 2 is defined to be 6, that means this is limit 6 to 6. So like upper and lower limit is same, this is also 0. But are they actually 0? Once again the question, are they actually 0? No. It's a 0 by 0 form, it's an indeterminate form. That means this is tending to 0 and this is tending to 0. Because your x is tending to 2, it's not exactly 2. If they are exactly 0, I can't do anything about the problem, right? I can't solve the problem. But because they're tending to 0, so because they're very, very close to 0, something like this, 0.0005. So 10 by 5 equal to 2, though they are very, very small, these two, but their ratio is some 2, which is finite. So that's why I'm doing this problem, because the ratio can be finite, because this part and this part, both of them are tending to 0. They're very, very close to 0, but they're not exactly 0. So whenever it takes a 0 by 0 form, when it's not exactly 0 by 0, but it takes a 0 by 0 form, I can apply L'Hopital's rule. So L'Hopital's rule says that I have this as my numerator, f of x 4t cube dt divided by x minus 2, limit x tends to 2. And when I put 2, it's taking a 0 by 0 form. When it's tending to 2, it's taking a 0 by 0 form. So I differentiate this, So differentiation of this is very, very simple. It's simply by 1. But how about differential of this? For this, we use the Newton's Leibniz rule. So how it goes is, you put f of x here, so it's simply 4 into f of x whole cube instead of t into f dash x. So differential of the lower limit minus, you put 6 in instead of t, the lower limit 6 cube, into differential of 6, which is 0. So right, this is the formula actually. So if f of x, g of x, k of t dt, if you want, this is your capital f of, this is your f of x, yeah, this is your capital F of x. If you need f dash x, you simply put k into g of x into g dash x. So put this and take its derivative, multiply, put this and multiply with its derivative. This is your f dash x. So I just did that here, like I just put f of x here and differentiated it. This part became 0 because 6 dash is 0, so I simply have 4 into f of x whole cube into f dash x. And I'll now put x tends to 2 for this, and this limit and the actual limit will be the same, right? That's what L'Hopital's rule is. So f of 2 is given to you as 6. This is 4 into 6 cube, and f dash of 2 is given to be 1 by 48. So this is 1 by 48. So this is something like 6 into 6 into 6 into 4 by 48. This is 6 8s are 48. This is 4 2s are, and this is 2 3s are. So 6 3s are 18. So the answer to this question is 18.